Dear professor and classmates, I will talk about our current manufacture progress. We have now completed the metal position, and in the next week, I will complete the entire sensor production. The following is the wafer cleaning process and the equipment which use Piranha solution for cleaning. The following is a special operation video.
Place the wafer in a beaker. Then pour in 100 ml of sulfuric acid. Pour in 50 ml of hydrogen peroxide. Keep the damper closed while pouring hydrogen peroxide, as the reaction will generate a lot of heat and sulfur dioxide. Rinse the beaker with dewater. Wait 50 minutes. Pour the discarded Piranha solution into a temporary storage beaker. Then use the water to rinse the cleaned wafer for about 5 minutes. After rinsing, only about half of the water remains. It is then transferred to an ultrasonic cleaner, where it vibrates for about 15 minutes. Rinse with the water for 10 minutes. After rinsing, take out the wafer and blow dry it with an air gun to remove moisture from the surface.
The following are the oxidation type. Oxidation will protect the silicon for TMAH etching. The rear picture shows the wafer after oxidation. The special operation of oxidation can be viewed in the following link. Next, we proceed to photolithography. First, we use Piranha to clean the mask base and below dry. and then stick the mask to the base. We use the following parameter to spin coating the photoresistant, and then bake it at 90 degrees for 90 seconds to remove moisture and cure the photoresistant. Then transfer to the other side of the wafer and do the same operation. Next, fix the wafer and mask for exposure. Bake again to completely remove the moisture in the photoresistant. Then develop for 60 seconds and streak continuously to speed up the development process until it's fully developed. Finally, rinse with dry water and dry. Observation of the sample and a microscope was constant with the actual pattern. Finally, the sample after the first lithography was obtained. Then BOE etching is performed, which mainly analyzes the chemical property of the BOE solution to etching the silicon dioxide material. They will be removing the exposed oxide layer. The specific stepper placed the wafer in BOE solution for 4 minutes to remove the silicon dioxide not covered by PR, and then rinse with dry water. To prevent the PR from affecting the TMAH etching process, first rinse the wafer surface PR with acetone, then rinse with IPA alcohol to clean the wafer surface, and finally blow dry with an air gun. Now then, part of silicon surface is exposed to the air. Silicon etching can be performed. First, remove the oxide field that was briefly exposed to the air. Then place the wafer in the water to prevent reoxidation. Then assemble the fixture to fix the wafer. Then place the fixture in the TMAH solution, etching at 80 degrees for 1 hour and 40 minutes. Then remove the wafer from the fixture. Rinse the wafer with dry water, and finally blow dry with an air gun. Since there are residual TMAH, BOE, and other solutions in the fixture, it needs to be cleaned and dried to facilitate subsequent use. Then we use the surface profiler to check the etching depth. Our objective is 50 micron. We measure 9 locations on the wafer and find that the etching depth is relatively uniform, or about 54 micron. The result basically meets the requirement. In order to prevent the TMAH solution from etching the silicon on the free side, we performed a second high-temperature oxidation to further protect the exposed part. The specific operation is the same as the first oxidation. The following figure shows the silicon wafer of the second oxidation, with a clear red color on the surface. In order to make a metal pattern, we use a sputter system to deposit metal, mainly through the collision between atoms. Metal iron will deposit on the wafer surface. We use chroming for deposition. After loading the wafer, in order to achieve a 200 nanometer thickness deposition, we set the power to 50 watts and the deposition time to 1 hour. The video shows the deposition process. Finally, we obtain the wafer after deposition as shown in the figure, and the color is gray. Thank you for your attention.